Just members.
Yes, I can hear you.
Hello?
Yes, please.
You're not talking.
Yes, because may I start? So we have
Henry,
an order that we are following.
But we can go on.
Doctor was saying something, but he's blinking.
am I clear now?
Yes, I can hear you now.
Okay. So, Henry, your group wants to present, eh?
Yes. Group 3 is ready.
Okay, please go ahead.
All right. Let me share my screen.
Please do.
So able to see something?
Yes, I am.
Even now?
Yes.
Yes, so good evening everyone on call. For those that
Evening. Good evening, Henry.
it's their first time, this is Henry. Yeah, this is Henry Sebunya. I'm taking Masters in Information System, and during our last session with Dr. Shiba, she gave us an assignment, and that assignment we had to select a topic that we are going to look at and be able to answer the questions that she had suggested. And our group is Group 3. Currently, we have a number of 7 members. So on your screen, those are the names. I have Pius, Fred, Flavia, Hilda, I, Eric, and Amos. So straight, I'll go to the first question. The first task was for us to identify or select the article that we are going to look at. Article that we selected. If I read for you on your screen, it is the Ultrafit Design Science Methodology for Smart Metering Design in Developing Countries. So if we looked at the document, that was the research, and this research was done by Julius and Peme, that their main idea, maybe I can try to break for you the topic. The word retrofit, it's mean in normal English, it means you to look at an existing system or an existing process of the way of doing things with the objective or the idea of improving it. So here in this research, they were finding a way of how they can improve the existing utility metering services so that it can have more features and more capabilities into the developing countries. And it was carried in case study, that was Ghana, where they looked at it and carried their research. So that was the topic that we chose as a team. So the next question, it was about for us to identify the research areas that was tackled by the authors of this paper. And when we read through and we discussed with the team, we were able to find out that the research of that paper, it tackled the implementation of the smart metering system in developed countries that is to be achieved by retrofitting traditional meters with remote meter reading capabilities, control embedded with security features. So here, what I can explain is that the researcher in these developing countries, they had a challenge, and there were many actually challenges that the users were facing, the customers who were paying utilities. In utilities, we can take an example of electricity. They had traditional meters, and these traditional meters, they didn't have remote capabilities. Remote capabilities, I mean that it can be controlled remotely, you can turn it on, you can load credit, and it can be remotely troubleshooted. These features were not on those traditional meters, but the researcher was looking in a way that how can they come up and implement the smart features? The smart features, I can mean that when they upgrade the meter, it can have capabilities of being monitored remotely. It can be able to communicate with the server. They can implement security features on that remote. So the researcher, the main thing that we are looking at, how are we going to improve these meters, but without removing all of them, that getting rid of them at once, but how we can improve it with improving new features that can be able to acquire the capabilities of smart meters that they had already done research in USA and South Africa. So I don't think whether there is any question, or I can be proceeding up to the next slide, Doctor.
Please proceed.
Okay. Then the next question was for us to identify the problem or the research gap that the author, they were trying to solve. So according to the research that we looked through and we discussed with the team, the researchers having carried out the research in these developing countries specifically, I mean Africa, and Africa is not basically a developing country, but in the case study where they looked at Ghana, they were able to identify the persistence efficiency of using the traditional utility meters. And these traditional utility meters, I told you they had challenges. Actually, these challenges included the manual metering reading, where the utility providers had to travel to the homes of the people who are utilizing the service to take the recording. And even another challenge they found out, it was about long queues for purchasing credit units. In case you want to pay for your utility, you have to go to the service provider, you line up. And also, reconnection delays after being disconnected. The clients who are using the service, we found out in the research that they had challenges where reconnection would take long. Because as you see, before, for example, in Uganda, before they introduced these cars, you had to go for the line, you pay, you line up, you take your invoice, the bill they bring to your homes, by that time to the Umeme people, they give you units, you load, then someone has to come and reconnect you in case he was reconnected. So this research, basically, even in Uganda, we had such challenges. Another challenge that we found in the research, it was undetected utility thefts. People used to connect themselves because these were traditional meters where someone can find a bypass and consume utilities without paying. So then another thing that although the smart meters were well organized as a solution to these challenges, their large-scale adoption was financially unfeasible for most of the low-income countries. Here, what the researcher meant that if they were to enroll the smart meters at once and say, let me give an example like in Uganda, let's just remove all the manual meters, it will be an expense. And you find out that the institution doing that, or the economies, the countries, it might be economically burden to them. And also, moreover, while the design research methodology provided a structure framework for designing and evaluating new artifacts, it is less suited to the constraints that where smart meters already exist but need to be adapted to the local realities. So here the researcher was suggested that wisdom being in other developed countries where that use this research methodology to apply, but it needed more people to engage in so that they can have the reality feel of it in case they were to implement it in these low developing countries. So also here, we concluded by saying that the core research gap therefore lies in the absence of a methodology and a cost-efficient approach to retrofit existing traditional meters into the smart meters instead of replacing them outright. When I proceed to the next was it was requiring us to give the research or the artifact that was based on to alive to the research problem. So here, when we looked at the research, and as we discussed with the team, we were able to find out that the authors of the paper, they were able to deliver, were able to reach to the research problem based on these streams of work that we were seeing on the screen. The first one, it was the design science research methodology. When we looked at the research, it was indicating some literature where this design was used in USA and some applied in South Africa, where they looked at it. They were able to implement this smart meters, and they were able to be adopted by the local people. So this one, the researchers emphasized the creation and evaluation of these artifacts. Secondly, we looked at the literature of smart metering. Here, we looked at the benefit of having accurate billing in case that his meter is local but has been given the capability to communicate with the server. The service provider was able to receive real-time consumption in terms of unit, what the customers are using, and even in terms of fraud detection. According to the research, it was able to detail and was able to show examples where real-time feedback from the meter, it was showing the trend of consumption of the utility. In case a customer yesterday was consuming 5, but today is consuming 10, another time on business consuming 4, the system was able to detect that fraud detection to the system, and also improved energy management and also customer empowerment, because when they do outfitting these meters, the customers were going to have capabilities of checking their meters via mobile. They'll be able to receive notifications in case they are running out of credit. Secondly, the research also based on the communication technologies to reach to the research problem. Here, they looked at the ZigBee, GSMS, GPRS. These are the communication technologies that they had implemented in South Africa and USA when they were rolling out the smart meter. These technologies are in a way that they are the one that give capabilities of the meter to communicate with the server. So these communication, the researcher looked at them before they reached to their research problem. Lastly, it was the area contribution by other authors. So we looked at that research and found out that the researchers, them being that they were looking at solving a problem or finding a problem, but they had also to look at the previous research that was done by other people in terms of the communication and in terms of enabling the traditional meters to have the smart features. So the next question was for us to identify the research objective that was selected or was identified by the researcher or by the authors in that paper. And after discussing and reading through with the team, we were able to identify that the aim of the research was to design a GPRS-based retrofitted smart metering system that could be applied to the traditional airstream meters in developing countries. Here, what we understood, like for the researcher, reason being the clients, the customers were using the traditional meters. So for them, their aim was to improve these meters by giving them capabilities of smart metering. And reason being Africa, the case study they were looking at, they chose the GPRS and the GSM as the simple communication that can be managed financially by the developing countries. And according to Africa, it would give the better reading depending on the infrastructure we have for communication. So there are also, this research looked at integrating the GPRS communication technology into the meters through a retrofit design. I say again that retrofit design, it means there is something already existing, but you want to improve it. The second one was to design a metering information system that would allow utilities and customers to interact remotely without fitted systems. As I told you in our second last slide, I told you that the customers would have capabilities of monitoring their utilities, and even the service provider would have capability of receiving real-time communication and be able to disconnect or connect in case of there is any change they would like to do on that meter. So they also, the objective was to come up with a metering information system. As we know, something that is a metering information system, it means going to process data, process information. How will the information come into the metering system? According to the research, these local meters, they're going to be added features of communicating using the GSM and the GPRS. So when I go to the next slide, the next slide was requiring us to identify the research method. The strategy was applied by the authors while they were doing their research. And we were able to find out, according to the report that we read, that the authors adopted a modified design research approach. Remember at the start, I told you that the meaning of retrofit and the main aim of this research was not to replace everything with a new thing, but like to remodify, to add, to enhance the existing traditional meters. That's why they adopted a modified design science approach. And for them, they gave it a name as the retrofit design science research methodology. Unlike the traditional design science research methodology, this framework, according to the authors, was fairly constant, where artifacts said, but needed redesigning. I think now you can be able to get the idea that everything here they are looking at, how can we give more capabilities to these traditional meters so that they have the smart features. The next one is that this involved the relevance identification and establishing the necessity of retrofitting traditional meters in developing countries, and carry out imperative system design. Imperative system design, it means that you have also two systems. Maybe, let me give you an example. You can have a system, let's say a car, we want to improve it. But for us to improve it, we must carry out what they call imperative system design analysis. In that system analysis, what we shall look at, we shall compare what are existing challenges and what are existing problems, and what are we proposing, what new features are we proposing. We do analysis and we compare these two and see the best solutions that we can come up. So that is about comparative system design. In addition to the authors, they examined the prototyping of the proactive profit system using PCI controllers. This one being the traditional meters, they never had capabilities of communicating. So for us to be able to use the features, like for it to be able to store, for it to be able to communicate to the server, they used to have microcontrollers. And these microcontrollers are going to be connected with the storage and then the GPRS communication module. This module is one that will give capabilities of the meters to be able to use the GPRS to communicate over the normal telecommunication network we have, and also they were able to incorporate the D5 security mechanism. Lastly, finally, the author evaluated the design by testing the retrofit solution against the standard meter functionalities. So how were they able to do that? Remember, I've told you they carried out an imperative system analysis that was able for them to identify the problem and able for them to identify the best solutions on how they are going to implement the solution of improving these traditional meters so that they can have those functionalities of a smart meter. Then the last one, it was that the doctor required us to identify the results or the findings of this research. So after having went through the documentation, the report of the authors, we were able to find out and we were able to conclude as a team that this research yielded the GPRS retrofitted system metering system which successfully enabled traditional meters to perform more core functionalities. These functionalities basically included remote meter reading, where I told you that the service providers, during the case study that they tested in Accra, they were able to receive real-time reading of the utility of the customers that we are testing. The utilities here, in example, it can be water or it can be electricity. But here, as per the research, they're looking at electricity. Fraud detection, remote disconnection and connection, in case your utility credit units are done as a client, you can be able to purchase. In case they are done, the service provider has capabilities of disconnecting. How they disconnect it? Through the GPS communication that was included into these meters. And also the client had the functionalities of topping up the credit units. 2 prototypes were deployed under real household conditions. That is Accra, Kumasi, that was in Ghana. The findings of the author indicated that the retrofitted solution performed comparably to full integrated smart meters. Stakeholders' feedback from the trip provider also, as per the author's writing, it confirmed that the retrofit design was cost-effective, scalable, practical, and it was offering a realistic pathway for electricity utilities in developing countries. Remember, the track that we chose, they wanted to find a way how they can redesign these existing traditional meters to give them the functionalities of a smart meter without replacing them. The reason why they did that, because in Africa, most of the African countries, they have income challenges. So replacing all of the meters in a nation at once, it will be a burden to the country. The author concluded that the study concludes that the RDSM is a visible framework for designing affordable smart metering solutions in resource-restrained settings. By retrofitting existing infrastructure, it offers a way to significantly lower deployment costs while preventing the essential benefits of the smart metering technologies. So that was from Group 3. I don't know if any member from Group 3 can add on what I've presented. Any questions?
On my part, it's not a question, but it is to say this was well done. And I think one of the things that I want to bring out, we were discussing with another professor, there's a student who was supervising, about research in ICTIS, anything to do with an artifact, where there's an artifact that has been developed. You design an artifact, then you evaluate. The results of your evaluation is what you report back. Or you introduce and your contribution is on methodology. So this particular article was specifically focusing on that. It was introducing a new method or a redefined methodology for a specific context. So one, I appreciate the group's work. This was very well done. Thank you, Henry. I think anyone who's listening to you understands exactly what this research was about and bringing out the research concepts. Thank you, Henry and team.
Welcome, Doctor. Again, thank you, Group 3.
Can we have
anyone else? So we go to the next one.
Can we have the next?
Thank you, Doctor. Let's have the next group.
Good evening, members.
Good evening.
Good evening, Kaluya.
Thank you. This is Kaluya Emmanuel, and I'm from Group 1. Allow me share just a minute. Okay. The screen. Are you about to see my screen?
Now, yes, we are.
Okay, I don't know whether it will allow me to.
I can see your screen.
I don't know whether it will allow me to use my. Is it moving on your side?
We see the
No.
mouse moving. May I see the mouse moving?
Yes.
Now I've seen it. You've gone to a slide 2. Now slide 3.
Okay.
Yeah.
I was trying to test my gadget if it's going to work well for me. Good evening once again. This is group.
Emma, sorry to interrupt. Try putting it in presentation mode.
Okay. I can see the icon for presentation mode.
It's look on the lower right. Are you seeing where there is a bar to zoom in and out? Yeah, lower right, extreme lower right.
Extreme roll, all right. Okay.
Yes, perfect. Yeah.
I don't know where I can put this one. Yeah. Okay. Doctor, we also did the same research. We looked at the retrofit design science methodology for smart metering design in developing countries. Those are the group members, myself, Edward Kayanja, Chikomeko Peter Grace, Kiza Gloria, Kintu George William. Sorry, I have repeated Edward Kayanja again. Then Leombia Pius. And these were the questions we were meant to answer: the research area, the research problem or gap, previous research, research objective, and research methodology. So in our, this one, okay, in our discussion with the group members, this is what we identified as the research area. The research area was the use of smart metering systems in management of utilities like electricity in the developing countries. Because when we read through the article that had been presented by the authors, they were majorly looking at how they can innovate or use smart metering systems that would help them overcome the problems with the non-traditional metering systems, like the queuing up, then the reconnection fee and all that. So this is what we identified as the research area. Then the research problem or research gap. We identified that there was need to use internet web-based applications to focus on how traditional energy meters can be aided to stay online through mobile application systems available in the developing countries. So thereby requiring them to come up with this new research, they call it a retrofit design science methodology for smart metering design. Because when we read, there is somewhere where they said that what is it that we are going to do with the non-traditional meters if they go smart, if they introduce the smart meters without considering the non-traditional meters, then what would become of the traditional non-smart meters? So this entire research was majorly focusing on how they could go smart, but not just throwing away the traditional non-smart meters. So they were looking at how they can just improve on the traditional meters, come up with something new, but which is affordable and easy to deploy. So in the research, they come up with their retrofit design science methodology, which helped them to embed or to reuse their traditional meters and make them the smart way, such that you don't fall into the problem of what to do with the traditional meters. That is what we identified as the research problem or the research gap. Previous research, the best one, there was research, the design science research methodology, which introduced the smart metering, but was expensive in terms of deployment and was going to make many of the traditional meters redundant. That's how they came up with the retrofit design science research methodology. So what we identified here is that there was some previous research which had been done on traditional meters and on smart meters. That's what we identified as the previous research that had been done prior to this very research. The research objective. Here we looked at what we would consider to be the main objective of the research. And to us, the main objective of this research was to design a retrofitted GPRS-based smart metering system for electricity utilities in developing countries. There could be other objectives that we could consider, but we majorly looked at what could have been the major objective of this research. This is what we identified with the team. The research methodology or strategy, we looked at these two, where we have the action research. This is research strategy that aims to simultaneously investigate and solve an issue. Research is conducted and action is taken and at the same time. In this case, the research was aimed at developing a new system for smart metering electricity. So for us, we identify this as a strategy because when they investigate or when they come up with an idea, they didn't end at just researching, but they also came up with the design, the retrofitted GPRS metering system. So that's why we said that the strategy was action research, and this other one, just allow me lift this such that I can read. Okay, and the other one is a design science research. This is defined as a legitimate research paradigm in information systems that focuses on the development and evaluation of artifacts aimed at addressing specific goals and design theories. This also feeds into the first one, where they were looking at developing an artifact and have it evaluated to address a specific goal. And the goal was to come up with the new GPRS-based metering system. Just a minute, my screen is freezing. Does it move so fast? Okay, the last one was the result of this research. In our view, at the end of the entire research that these authors were looking at, or what they have documented in this research, the major result was to design and implement, and the implementation of the retrofit design science methodology, which led to the design of a new smart metering model, which is a GPRS-based smart metering model based on existing traditional meters. Like I said before, they had an issue with what to do with the traditional meters. So the end result of this research was to develop a model that would use the traditional meters, but in a smart way, addressing all the problems that would be in the traditional meters, but then not just throwing away the traditional meters. That is what we looked at with the team. I don't know whether there is anyone in group 1 who has something to add on top of what I have presented. Thank you.
Thank you so much, Emmanuel and team. Thank you for the good work. And I think you are quite clear on your concepts. Thank you so much, Emmanuel. Can we have the next group?
Welcome.
Yes. Good evening, members.
Yes, good evening,
Good
Henry.
evening to you.
Good evening.
Yes. Let me try to share my screen. I hope you're able to see my screen.
Yes, yes, I am.
Yes, I can see.
Okay, so our group is made out of the computer forensics students. That is myself, Henry Ndaula, Martha Komhanji, Moses Galio, and John Bosco Ocheng. I would ask Moses. Moses, are you there?
I'm there.
Yeah, you can take the lead.
Okay, like you help me to scroll. The next. Okay, let me first start. So, good evening, members.
Good evening.
Good evening, Keaton.
Our focus was basically on the article. We are working on computer real-time location forensics methods for network intrusion. So we are basically our focus was basically on looking on identification, preservation, and extraction, documentation, and interpretation of digital data, basically for legal purposes. That's the area where we focused on. So when you look on, can you go to the next slide, Henry? So our research area, we had what we call the domain. That is the computer forensics, the network forensics, and intrusion. So with computer forensics, according to the article, we are basically focusing on the identifications if someone is on the network. So the authors were basically focusing on those basically focusing on monitoring and capturing plus analyzing the investigations that are basically if someone is trying to do something online. So the authors were basically looking on that. How can they analyze what is taking place on the network for easy security incidents that could be what could happen. So the focus was real-time evidence collection and analysis for network intrusion crimes. These ones we have very many. For example, we have what we call DOS, denial of service attacks. how can we investigate this? How can we even prevent it from being what? From happening using the K distinct cluster based on the K distinct clusters. So we have another one, that is the case detecting the disk operating, the denial of service. You're so fast here, Henry. We have the case. How can we detect, like, for example, we have what called the denial of service attacks using improved K means clustering algorithms. So here we basically we looked at the article and went so deep to see how unsupervised machine learning algorithms used by the group basically to look on those features on how they could detect using the algorithms, depending on the article, how they could detect who's trying to. For example, we have in a DOS, we have someone might try to create traffic on the network to make the service unavailable to other users. So we try to go deep and look at that. So our case study, according to the article, was basically on detecting the DOS attacks using the improved K-means clustering algorithm. So we can go to the next slide. So the research gap, we look at what we call the traditional forensics. Here we have what we call the post-attack analysis, often losing evidence. So we went through the post-attack analysis on how, basically often or losing evidence. Then the intruders erase trace. Here we looked at unreliable evidence for legal cases, and another one was a lack of real-time dynamic forensics methods, which sometimes causes loss of documents, malwares in systems, and next we had what we call existing models weak in accuracy, speed, and fraud attack handling. That's what we basically looked at. So my colleague is going to take over. That is, I think Henry is going to take over from there. Henry, are you there?
Yeah. So continuing, I'll look at the previous research that the authors looked at. One of them is Sun et al. Looked at some of the challenges that are happening with network intrusion systems modeling. Another author looked at, that is Hodo et al., 2016. In the article, they looked at some of the challenges with DOS, that denial of target detection, where there is also high latency in the network. And also, they also looked at some of the computer forensics principles to preserve evidence. So there were some challenges with the previous traditional methods where in event there's an incident, is more or less after the incident has happened. And then they also looked at a study on the improvement focus, especially on the speed and accuracy of the clustering algorithm that my colleague looked at. Then also what were the objectives of this article? So the authors were proposing an improved k-means clustering algorithm. And what was it to do? To accurately detect intrusions in live network traffic, as opposed to investigating packets of traffic after an incident has occurred. And then they're also looking at achieving real-time processing speeds as they analyze data. Then they were also proposing outperforming the traditional clustering in accuracy and efficiency. What were the research methods that they were looking at? There was an approach of a combination actually of quantitative. There was also simulation-based and experiential in nature. They looked at certain forms of data where there was large chunks of data, looking at dataset like the KDD9 datasets. Then there was a comparison with the traditional forms of investigation in network traffic versus the improved k-means clustering algorithm. And they also looked at simulation attacks with some of the networking protocols like UDP, ICMP, and also performing TCP flood attacks. So that inclines the simulation based. There was also looking at some of the performance metrics and in comparison, specifically looking at the accuracy rate and false alarm rate and also the failure rate of both the traditional methods of investigation in network traffic and the improved k-means clustering algorithm, which was found to be much faster in all those comparisons. That is the accuracy rates, the false alarm, and the failure rate. Okay, so I'll ask Martha to take on the findings that we discovered by the authors.
Okay. I'll check off. So according to the author, we found out that the improved k-means algorithm that was highly accurate and it had low errors compared to the traditional one. Then another one, better detection under the UDP, ICM, TCP, flood attacks. Also, this improved k-means algorithm, it was the way of detecting its data was better than the traditional one. Then another thing, it was faster processing. For this improved k-means algorithm, it was faster. It's the way of tracking data, it is faster than the traditional one. So we found out that the improved k-means algorithm was faster than the traditional one according to speed, on how the speed of tracking data. Then another one was effective for real life forensics analysis. we found out that this improved K-means algorithm was effective. In real life, they mean like when there is a certain attack, maybe in the network, if someone used this improved K-means algorithm, the data would be collected easily because it is fast. Again, it is better. You can get the information at the time it is needed. So in conclusion, we found out that they developed improved K-means algorithm for real-time forensics. Another one was more accurate and faster than tradition. We found out that in conclusion, the improved K-means algorithm was accurate and faster than the traditional approach. Then practical for law enforcement and security professionals. It is also user-friendly for people who are collecting data or evidences. Then enables evidence collection during attacks and stronger prosecution. That means in case of any attack, when this K-means algorithm is used, it can enable those people doing some investigations to collect their data in time and accurate.
Okay, I think that's the end.
Thank you so much, Henry and
Any
team.
question?
Thank you so much, Henry and team. I think on methodology, though we haven't covered it, methodology, primarily I think they must have used the experimental, it's called sometimes laboratory experiment method. I think you picked it out there. I think that's why they did the simulations and so on and so forth. So thank you so much. This was also well done.
Thank you.
Can we have the next group? The forensics group has only 4 students, so that's why they make up only one group.
Yes, correct. And sorry, I had forgotten. My colleague John Bosco Cheng was unable to speak in this presentation. He's kind of under the weather.
Oh, sorry.
Apologies for that.
Sorry about that.
But he's on call.
So I think I'm going to take on to present for our group. So this is group 2, information systems. We're going to take you through the retrofit design science methodology, just like the other classmates of mine have done. And yes, these are members in group 2, Chizito David, Chivuna, myself, Solomon, and Emmanuel. So the first question in the assignment you gave us was to talk about the research area tackled by the author. So basically this research paper had 2 authors, and what they were looking at, they were basically looking at the broader context are literally metering systems. But particularly, they were drawing it down to traditional meter systems and the smart metering systems which they want to come up with. Due to the challenges these traditional systems bring in our lives, they decided to just look at other papers and be like, why not come up with smart metering systems that we can use in Ghana? Since this research paper was actually done in Ghana. So they were finding a way to introduce this communication and control units in the smart metering system that they can use in their country. So the research gaps that the author was trying to resolve, there were mainly challenges that come up with traditional metering systems. In their country, they were basically using electricity, but I think in Uganda, our electricity is more of the smart metering systems they're using. So we can basically put it in the perspective of water, since most of our things are done manually. So in the gaps these authors mentioned, these two authors, there were manual meter readings, whereby these people from their utility stations had to come and manually read their customers' bills or all the meter readings, and then they go back and do everything manually. So with this, it cost a lot of time wastage. People would, have to move from their homes to these stations to actually get the actual units, and also fraudulent connections. It's very common, even in Uganda here, where people are even still stealing water, electricity because of these traditional methods. So there were literally gaps that were being brought up by these traditional meter systems that they were trying to work upon. Yeah, and they're listed on the screen, just that most of my classmates have really talked about everything. I just don't want to keep on repeating everything, but they are basically the same. What's on my screen, it's also what my classmates presented. So when you talk about the previous research, these authors, based on to come up with theirs, there were a number, there were a number of them, although we listed just 4. One of them was the existing DSRM models. That was under this particular Hevner person, their paper. And if you read through the research paper, you realize for them, they came up with only a model, but they wanted somebody who could come up with a construct, a model, a method, an instantiation, and a better theory. And according to them, they believe that theirs had all these aspects that they were looking for in this retrofitted system. They also went ahead to look at a research paper on smart metering security issues. The fact that they were working on coming up with a smart metering system, this needed a lot of security, because when it comes to information systems, you really need to secure it so that people do not mess up the information in it. So they are going to employ an MD5 algorithm that was already used by someone in his or her research. Then we also had the studies on GPRS, these modules and embedded systems for communication in smart grids. They also went ahead to look at that paper, and they said, why not come up with a smart metering system? And also other literature papers that were actually outlining the benefits of these smart metering systems, since developed countries were already using it and it really was effective. So they also found that, yes, if it's working in other countries, why not in Ghana? Yeah. So when you look at the research objective, their major or the main objective was to come up with a retrofitted GPRS-based smart metering system for electricity utilities in developing countries. Developing countries are particularly narrowed down to Ghana, since they were located in Ghana. But under the specific objectives, things that will help them to achieve this main objective was to implement a communication and control unit. This was going to be as an embedded system, because these systems cannot be, embedded systems. It's things to do with tracking for those who have done embedded systems. Then there's also to develop a metering information system for remote monitoring. But the fact that it's going to be smart, that means it needs to be monitored remotely. Everything is going to be done remotely. So it actually isn't work. So these were the specific objectives that they would use to actually attain their main objective. Then when they say the research method that they applied the modified design research methodology, particularly the retrofit method. So I went ahead to actually find out what this method is, or, it mainly deals with things that solve real life problems. Because if you look at some research papers, they are just theories, things you just want to actually happen. And when you look at it in the aspect of life, it actually does not happen. So by the time you're actually using this science, this science research methodology, it means it's actually going to solve a real life problem. And for them, they added on the retrofit method because the system is already existing. So they're just going to add some units or some systems to actually modify the traditional metering systems that were already existing. So that was the method they employed to actually come up with their final product. And if you look, they go ahead to list different stages through which they're going to come up with, through which they're going to use to come up with the final system, which the first stage was the relevance identification. And this was just to find out the reason why do we actually need this system in these developing countries. That's relevant, how important or how good is this system going to be in our country. Then they go to compare system analysis. It's comparing traditional and smart meter systems. Which one is better? Why should we go for this one? Or what does this one have that the other one does not have? And then the design and development. Of course, they came up with, if you read the research paper, they came up with 2 meter systems and they performed, 2 artifacts that they used to perform the tests on, and they realized it was actually working just as they wanted it to work. And then the comparative evaluation, I think it's what I've just said, testing. After coming up with those 2 artifacts, they actually tested these systems and it was doing what it had to do. Then communication, publishing results for knowledge sharing. I don't really think they built the system. But then on the research paper, of course, as we have seen the research paper, they published their results for which us right now, we are using it to expand our knowledge. And the results, stroke findings of the research, at the end of the day, it narrows down to coming up with that system, the GPRS retrofit system. And yeah, they were able to come up with it basing just, on paper. And at the end of the day, they also said this system was going to be able to reduce the cost of deploying smart meters in developing countries. Although it wasn't going to be deployed at once. No, it's expensive. But at the end of the day, if things were to be put in place, it was still going to, it would be better in the long run compared to these traditional systems. And in between the slides, these 2 points, those were just methods they were showing us in the, because when you talk about findings, you can either talk about the findings these authors based on or used to come up with their own research, or their findings from their own tests and the tests of TEST. Yeah, and these were just methods they used to come up with the server. There are actually images in the paper that show us how these 2 points in between were being used. Yeah, so that's what we had from group 2. Thank you.
Thank you so much, Group 2, for your work.
If there is anyone in group 2 that would like to add something, the floor is yours.
Since we had already discussed about it, whatever you're saying means all of us consented, so there's nothing useful.
Thank you for the good work.
Welcome.
Can we have the next group? Is there another group? Is there anyone from ICT? Any group from ICT that may be ready?
The members for the different programs are spread out across the groups. I hope I'm right on that. Because I'm ICT, but I belong to group 2 that just presented.
Hey, okay.
Yeah.
Is there any other group? Hey, has everyone presented?
Look, I think many of us have presented, except for members who are new that do not have groups.
Okay. So that one, I think that one is understandable. For those who are new, I think we can think of something else to make up for that assignment.
Doctor, maybe I don't know whether how many they are. I know of one because she has been talking to me from IS. She's called Agnes Nabuf. I don't know whether there are others, and if they are, they can join it together to come up with a group.
Yes, please. That would
I
be
don't know
good.
that she's only one.
I think there's also Richard. Richard is another one. Richard, maybe you could join up with who is the other one? Emmanuel?
She's Agnes Nabuf.
Agnes.
Yes.
Agnes, yes.
Maybe Agnes, you could join up with Richard Okello. He's
I
in
think
ICT.
Okello.
Oh, okay. Are we going to be 2 or should we expect more to come?
I don't know if
Maybe
there's
3.
anyone else. Is there any other new person?
But they're already 3. I can see Richard, Agnes, and someone called Okello.
I think Richard is Okello.
Hey.
It's one person.
Yes.
Okay.
No problem. We shall join together. And so, Doctor, what are you going to give us something new to work on, or should we also do the same?
You can do the same because there are a number of articles that I shared, so you can pick any of those articles.
Okay, please.
Okay. May I suggest then that we call this a day and meet tomorrow?
That's okay, Doctor.
Yes.
Doctor, before we go,
Yes, please.
I just have a question on let me just, I had written something here. Let me just look through such area. Doctor, on the research strategy. Yes, as much as we did something as a group and we presented, but I would like to understand what do we mean by research strategy? Because when I looked at what I think group 3, how they presented their research strategy, and how group 1, where I belong, and I think group 2, how we presented the strategy.
Yes.
Is a little bit different, though we were looking at the same research.
Thing. Okay. Now, research strategy is, yes. Research strategy.
It's okay, you can go on, Doctor.
Okay. Can you hear me?
Yes, Doctor, I can hear you.
Okay. So research strategy is the same as research method. What is the research method? And although we haven't touched on this particular part, there are specific research methods that exist. For example, case study, action research, design science, action design science, ethnography, and so on and so forth. So the question is the question always is, what is the research strategy? Okay. Let me see if I can pull out your particular article. Now, specifically for your article, it was looking at, it wasn't necessarily the artifact that was the output. It was trying out a new research method, improving on design science with the intention of designing an artifact that needed improvement, not a completely new artifact. That was the objective. So, in other words, these people developed a new research method and used it. Yeah? They redefined design science and used it. Have I answered your question?
Yes, Doctor, you have.
Yes.
Thank you.
Yeah.
And finally, possibly this is my last one.
Yes, please.
On objectives of the research.
Mm-hmm.
When you read the paper, like I said, there could be other objectives.
Mm-hmm.
Now, for this particular question, when someone gives you a research paper like the one we have been given,
Mm-hmm.
do we go ahead, do you identify the main objective and identify other specific
Yes.
objectives, or you
No,
can only look at the main one?
Just the main one, just what you perceive that it to be. And of course, it was it wasn't the methodology. The methodology was not being tested in this case, but the artifacts they were designing, of course, were the new meters, the improved meters.
Yes.
So that was the objective.
Oh, okay, thank you.
You're welcome.
Doctor,
Yes, Martha.
I wanted to ask you, because tomorrow you said you're supposed to begin at 9.
At 9, yes.